Right, question 5 is based on a flow diagram or a reaction series, which initially can look quite complex because there are obviously a lot of reactions illustrated in the one diagram. The trick to answering these kind of questions is to just focus on the part of the diagram related to the specific question, and that sometimes helps simplify it slightly. So 5.1 asks you to write down the chemical formula of compound X. There's compound X. So the reaction that we're interested in is that reaction there, ethanol reacting to form bromoethane. I'm just going to simplify it by just drawing the backbone of ethanol. I'm not drawing in all the hydrogens, but there's ethanol, and it reacts to form bromoethane, which is 2 carbons with a bromine attached. Obviously there are hydrogens around those carbons, but one can see quite easily that we are removing an OH and we're adding a Br. So it's a simple substitution reaction, and compound X that's required is hydrogen bromide, HBr. Notice that the question asks for the chemical formula and not the name. So HBr is the correct answer for 5.1. 5.2 asks you to use structural formula to write down an equation for the reaction of compound X and ethanol. So once again, it's the same part of the reaction series that we're looking at. When they ask you for structural formula, that means that you need to show all bonds in the reaction. So we need to do this carefully. Let's start with ethanol. It's got 2 carbons. This is where some people sometimes slip up. When you ask for full structural formula, you must show the bond between the O and the H, and then there are hydrogens attached there. Remember, if you want marks, you need to put in the hydrogens. For ease, I'm not going to put them in now. That then reacts with hydrogen bromide. Again, because you're using full structural formulae, you need to show the bond between the hydrogen and the bromine. That then reacts to form bromoethane, and the 2 carbons from the F and the bromine atom that's replaced the OH, and again hydrogens attached around those carbons. Now we've removed the OH, there's an H left over from the hydrogen bromide. That means water is formed, and again we have to show the structural formula for water, and so show the oxygen with the 2 bonds coming out to the 2 hydrogens. And there's your structural formula for that reaction. 5.3 asks you to name the type of reaction that takes place when bromoethane forms ethanol in reaction S. So again, we're focusing on this part of the diagram, but we are now looking at that reaction from bromoethane to ethanol. And again, I think it's helpful if we just summarize it by indicating there's our bromoethane, obviously with the hydrogens, and it reacts to form ethanol. So 2 carbons with our OH group. So what's changed? Well, the OH has come off. It's been substituted by, the Br has come off and it's been substituted by an OH. And so the type of reaction is simply a substitution reaction. Another name for a reaction where an OH is added is called a hydrolysis reaction. So you could also call this hydrolysis. So substitution or hydrolysis would have been fine for 5.3. 5.4 asks for the IUPAC name of compound Q. There's compound Q over there, and so we're now focusing on this part here. We have ethanol. And again, I'm just going to draw it so that we've got a visual representation of what's happening. It's reacting with concentrated sulfuric acid and heat, and you should be able to pick up that that is an elimination reaction, and so it's going to form ethene, and so compound Q is ethene. 5.5 asks you to give the reaction conditions for compound Q to form as one of the products from reaction U. Here's reaction U over there. So it's the reaction where bromoethane reacts to form compound Q, which we now know is ethene. And so the reaction is a haloalkane reacting to form an alkene. That's an elimination reaction, and the conditions for the elimination of a haloalkane are to heat under reflux, and then the other reagent that's needed is a strong base, and we can choose something like sodium hydroxide or potassium hydroxide. But the key here is that that strong base, whichever one you choose, needs to be dissolved in ethanol, and it needs to be a hot solution, which is then heated under reflux. And so the full conditions would be a hot ethanolic solution of sodium hydroxide or potassium hydroxide. So those are your two conditions. Firstly, it needs to be heated under reflux, and secondly, it needs to be heated with a hot ethanolic solution of sodium hydroxide or potassium hydroxide. And then finally, 5.6, name the type of reaction that takes place during reaction U. Again, it's that reaction there. It's the haloalkane, bromoethane, going to compound Q, which we said was ethene, and that's an elimination reaction. If you draw out the reaction scheme, you can see that you are removing hydrogen and bromine, so another term for it is dehydrohalogenation. You're removing the hydrogen and the halide bromine, so you remove HBr, and so either elimination or dehydrohalogenation would be the correct name for that particular reaction U.